you indicated to me. Good afternoon, good morning, good evening, wherever you are. This is a maths class, and we are going to be dealing with trigonometry. We welcome you, and for a brief introduction, the lessons that we are giving you are from Smart Caps, which is sponsored by VT Africa Holdings, along with other sponsors. Along the lesson, you will be required to do a few assessments. Remember, maths is very interactive, so you need to log into hellosmart.com, which is what we will be using for our assessments. You also have to sign in as a guest, as a student, and also the ID number here in red showing. So you simply add your name, and we want to see how far you can perform. So I would flash this ID number again later on as we will start our assessment. But this is the important part. You need to know that you're at hellosmart.com and the ID number for the class is that. Remember, you can use any device you have, whether it's a smartphone, your laptop, or any kind of gadget, as long as it's a smartphone. So let's get started into our lesson. Okay, so today we are going to be looking into the topic of trigonometry, which is a term 2 topic. And remember, we have done trigonometry in other different grades and also term. This particular one will be the 2-dimensional trigonometry, where we'll be looking at various aspects. Some of the things that we'll be looking into we'll be dealing with the area rule. We'll be also having a formative assessment on that. We'll also look at the sine rule, the cosine rule, and also we will go a bit into 3-dimensional problems. Okay, so let's start with solving in 2 dimensions. There are my shapes. Basically, we'll be looking at triangles in this topic. That's why we call it trigonometry. So trig coming from the word 3, and trigonometry is the measurement on triangles. So the first triangle is a right-angled triangle. You can see that this one is not a right-angled triangle, the second one, but we can make a right angle somewhere on the apex of the triangle. We can also make a right angle with the obtuse angled triangle to actually have a right angle there. The formula we are going to use, which you might be familiar with by now, is half base times height, which is a formula that we did from grade 5. We are going to model this formula a bit to cover certain angles that a triangle might have. So there we go. This is going to be our grade 12 formula that we use. And there are 3 variations of the formula. And if you have the lengths of 2 sides and the size of an angle between these 2 sides, then you can use these formulas to work the area of that triangle. So you have to make sure that the angle has to be in the middle of the two sides that are given. For example, if my angle is B or theta here, then I'm going to have a formula with C, angle B, and A. Remember, C small is telling us the length of the side opposite C. And B small is showing us the angle or the length opposite to B, either way. Also, small a is opposite the angle A on the other side. So this angle is an included angle. It must be between the two sides that are in the formula. So that's why it has three variations. If you are given the angle A, then you are going to use C and B or B and C. So it's half base times height, because the height in this case will be C sine A. If you are also doing physical science, you know that there are components of forces and all that. So a vertical component is sine, and the horizontal one is cos. So hence we have C sine A. Again, if your angle is B, then you are using A and C, half base times height, in this case, half AC sine B. Lastly, if you are using the angle C, your two sides that are around that, it's your A and B. Hence, your formula will be half AB sine C. So one of the hints to remember this formula is to make sure that you have all the three letters somehow in your formula. You can see that area equals to, there is somewhere where there is an A, B, C in the formula. Even this formula, it has A, B, C. The last one also has A, B, C. So you should generally make sure that you have all the letters somehow included. Of course, one will be the angle. Let's proceed a little bit to use these formulas on the next example. So this is an example that we can work with, which I'm going to show in two ways. I'll start with the example. If we have a triangle which can change the names, we don't always have A, B, C. It can be P, Q, R in this case. So what is the question? Given the lengths of P and R and the angle Q, rewrite the formula. So what is the length of P from the diagram? P is the side opposite the angle P. So it's 12 centimeters. So we have half PR sine Q, because we have angle Q given. So our P is 12, that's the side. Our R is 11.5, the other side, which is your R, and the angle in between is 46. Hence, we have half 12, 11.5 times sine 46, which if you use your calculator, you'll see that it will give you 49.63. And remember, the units for area is centimeter square or square centimeter. It can also be, depending on what measurement we are using, if these were meters, it will be meter square. If these were millimeters, millimeter square. All right, let's check what we can do. Okay, I'm just gonna give you a chance to have a look. So for those who are using gadgets, you are going to have a chance to do this on your gadget. Okay. All right, so this is the question. Those who are not using gadgets, you can clearly read the question here, and you can use a paper or your book to work it out, whatever is needed on this side. But those who are using gadgets, you need to connect to the class, which we mentioned earlier on. You need your ID. You remember that you go to Hello Smart, and then the ID number that you join the class with is that one. That's your 598751. Okay, so let's proceed. What information is needed to use the area rule? Do you need A, the length of all the three sides, or B, the length of the base and the perpendicular height, C, the size of two sides and the angle between them, or D, the length and the hypotenuse and one other side? So I'll give you just a few seconds to decide. So the question is, what information is needed if you want to use the sine rule? Do you need a triangle which has all the three sides given, or do you need a triangle with the length of the base and the perpendicular height? Or do you want to have information about the sizes of the two sides and the angle between them? Or D, do you want the length of the hypotenuse and the other side? So which one will be correct between A, B, C, and D? Okay, I think you have made your decision. All right, so if you were scribbling on a page, let's check what answer you were supposed to get. Okay, so your answer would be C, which is you need the sizes of two sides and the angle in between. Remember, as we explained, that we have to use the included angle between two sides. So you need the two sides and the angle in between. So your answer was C. Okay, let's go to the next part. Okay, there is another question. In this question, you are supposed to calculate the area of the triangle using the formula half base times height. So this is like back to your original mathematics where you're using half base times height, which we are still using. In this case, you don't have an angle in between, which is shown. But how do you work out the area of this triangle? So I'm going to give you a few seconds again to work on this particular exercise. Just to check if you are connected. Um, Okay, so let's get you started if you are using your gadget. So again, the question is to simply calculate the area of the given triangle using the formula half base times height. So remember, the height must be perpendicular height to the base. So you have 30 seconds to finalize your question. Let's see your answers. All right, let's check what we were supposed to do. In this particular situation, we don't necessarily have a base that is perpendicular to the height. And I'm just gonna go to the next part here to show you the solution. Okay, so there is still another question, which I'm just waiting for you to see it on your gadgets. Okay. So in this case, let's revise the previous question first before we start this next activity. We were given 10, which was sort of like the height. And then we also have the other side here, which is your hypotenuse. So in order for you to use half base times height, you need to decide what is your base. And if your base is this 15, which is the hypotenuse, you then need to have a height that is perpendicular to that 15, which we are not given that information. So it will be best for you to actually use this base, which is naturally on the ground. So this is your base, and then your height is this. But we don't have information about the length of this base. And yet we know that we can use Pythagoras theorem to get the third side. So let's check that one out very quickly. If I am to call this side B, for example, you can call it anything else, but B for base, I can say B squared is equals to 15 squared minus 10 squared, which is dating back from your Pythagoras theorem, where the hypotenuse is subtracting the other side squared. And from your calculator, 15 squared will give you something like 225 minus 100. And to get your B, you need the square root of this 225 minus 100, we can also just work it out to be 125. So you need the square root of 125, which is a length, so it will be positive, because a square root can have a negative or positive value, but we are taking the positive value. So I'll keep it like this, but if you have a calculator, you can get some values with some decimal places. So going back to the formula, this was just B to get the base. If I go back to the area equals 2 half base, which is my B, times height. Okay. You see that I can have half of B, the B is square root of 125 times the height, which the height, as we saw on the diagram, was 10. So you can use your calculator to get your final result, which is part of the answers we have here. So let's see what that will give us on the answer. So that will give us 55.9 centimeters squared as the area. Okay. I guess that you got it correct, and you understand how we used Pythagoras to get the base so that we can calculate the overall area of the triangle. Let's check that next question that is also relying on the principle of area and the sine rule. Okay. So while it's opening up on your gadget, again, we'll be looking at area of a triangle. Okay, I think you can see it on your gadget. The next question, which is question 3. Question 3 is saying, use the area rule to find the area of triangle ABC. So you're given a lot of information on the triangle. You have your A small, you have your B small, which is 9, you have your C small, which is 5. So I'm just gonna label that for you before you start your question to give the solution. So that is small a, that is small c, that is small b. Okay, that's quite a good head start. What are you given again? You're also given the angle C. So how are you going to get the area of this triangle? So I'll give you again a minute to look into this and come up with the area of the triangle. Okay, 30 more seconds. Look at it. Remember the formulas we have talked about. All right, that should do. If you are on YouTube, remember you can pause this video and make sure that you try to get the solution before you proceed to this section of the answer. So the question was, use the area rule to find the area of ABC. So we want to see if you got it correct. As I have already annotated, we have your small a, small b, and small c, which are the sides of the triangle. You also have an angle that is angle C, which is 77 degrees. So we are going to use a formula that includes the angle C, because remember we need two sides and an included angle. So this angle C is between A and B, which means our formula is going to be half AB sine C. And we have all this information. We know our small a and our small b. So just to substitute here, we would have half times small a is 7 centimeters, small b is 9 centimeters, and the angle is sine 77. So you might want to write a small s for sine, which is usually the convention. So with this, you need your calculator to find what is half times 7 times 9 times sine 77. Let's check what answer you were supposed to get. This will give us C, which is 30.69. That's to 2 decimal places, centimeter square, or square centimeters. So it means this triangle, from whichever area you look at it, you see that it will have the area of 30.69 centimeters square. Okay, you get feedback on your device on this question later on. Let's check our next activity. So we also have question number 4, which we are going to look into within a second, but it's looking at the area of another triangle. So as I said, triangles are not named ABC or PQR only. It can be any letter. It can even be some of the Greek alphabet. And in this case, we do have a triangle MNO. So on your devices, you can see the question number 4. Here's the question: calculate the area of triangle MNO. And you can see the diagram. On the diagram, we have this length given, that length is given. We don't have this longer length. And also we don't have some of the angles, but we have a 78 in the diagram. So again, I give you a minute to have a look at this question. So I'm giving you another 30 seconds. Check through how you can actually solve this small riddle, as it were. Okay, I think that could be enough to determine what is going on. So let's see what some of the answers you might have got. Let's find out what you are supposed to say. So this question doesn't have enough information for us to get the area. So our answer is D. Why is it the case? Because this triangle we are given, let's show the sides that we are given. We have small n opposite big N. We have small o, if you like. We also have angle N. This angle N is not an included angle. We are not given the other side, which would have been small m or ON. We don't know how long it is, so we cannot use the area rule to find that length. However, as we go forward, you see that when you have done what we call the sine rule, you will be able to solve this by first looking for other angles. For example, you could find the angle O using the sine rule. And once you have two angles in a triangle, you can find any other angle there. But so far with the formula we have, we don't have enough information to use the sine, the area rule, which is dependent on an included angle. So I hope that you discovered that as you were working on this. Let's go to the next aspect. Okay. So you are lucky that there's many questions coming to reinforce this area rule for you. So there is another question, number 5. Okay. So in this particular question, it says write the expression for the area of the triangle. So you have a triangle that is given, and I want you to decide how you can decipher or solve this particular question. You simply looking for the formula that would help us to find the area of the triangle. So I'll just give you 30 seconds. Okay. We don't have so much time remaining, but as well, you can pause the video if you are still working on this. But let's proceed to check what is happening in this question. In this case, you are not given the names of the angles or the sides. You can decide if you want to give names of these angles. You can also call it A, B, C, as long as you know which one is your A and B and C. For that order is important while you solve the question. But what information are we given in the diagram? We have the 14 centimeters, and we are told that the other side of the triangle is equal to this side, which is 14. So it means we also have 14 centimeters, because this is an isosceles triangle. If it's an isosceles triangle, which means we also have x at the base, because the base angles of an isosceles triangle are equal. So you already have two angles of a triangle, which means you can easily find the third angle. So the third angle that I'll show you will be 180 minus 2x, because we have to subtract the other angles to make to get the third angle, which is actually supplementary or add up to 180. So the sum of angles in a triangle equals to 180. We remove these two, we get the third angle, which means if you check our solution, you see that our answer is number A. Number A. And how did we get that? Remember, we have area equals to half base times height. In this case, our base can be 6. So it will be half of 6. And then the angle. So we need two sides, remember? So there is 6 and 14, and then the included angle will be sine x, which is this angle. So we didn't need necessarily to find the third angle, though you could use it as well. So this is what is giving us our solution, which is 42 sine x. Okay, so with that, I would want to end the lesson, and I hope that you actually learned a lot from what we started to look at, which is the area of a triangle using the sine rule, which is half AB sine C overally. So we managed to find out that the height doesn't necessarily have to be perpendicular, as long as you know the angle included in between. So be aware that you can still follow up on this lesson if you check on your YouTube channel. And we thank you. So we'll be having a lesson tomorrow. Log in into our platform the same way. Our classes will be starting from 10 o'clock. Roland. Okay.